In this tutorial, we're going to start thinking about non-response bias in surveys. We're going to use an example from the Framingham dataset that's admittedly a bit contrived, but I think it's kind of fun. So think about the Framingham study. This was a large, well-funded endeavor where participants volunteered to participate. Therefore, you really don't see much missing data in the Framingham dataset. However, think instead if we would have just called people up in Framingham and asked them to participate in our study. Presumably not everyone would have wanted to participate, and we would have had a lot of missing data. Now let's think about the following contrived example. We had people who came in at baseline and we got measures of their blood and we got measures of total cholesterol. So let's hypothetically suppose that all of those blood samples got lost. But the study investigators decided we don't really want to go in and measure the whole population again. So instead, what they're going to do is there's this entire Framingham population, and they've decided, well, let's just go in and ask maybe 400 people to return and ask them to come back in and get their cholesterol tested, get their blood sampled again, so that we can just get some estimate of P, which is going to be the prevalence of high cholesterol. And they just wanted some idea of what that prevalence of high cholesterol was at baseline in their cohort. Now, these guys, they're realistic. They know that all 400 participants aren't going to return for the retest. And in fact, they found out by looking at baseline covariates that willingness to return was correlated with frailty of the individual, sex, and prior knowledge of high cholesterol. Therefore, because willingness to participate in this retest was correlated with high cholesterol, we would predict that if there's a lot of missing data, we're going to get a biased estimate of the prevalence of high cholesterol. Now, in the original Framingham dataset, because this is a contrived example, I know that the true prevalence of high cholesterol at baseline was 43.1%. where I'm defining high cholesterol as greater than 240 milligrams per deciliter. Now, we're going to go ahead and we're going to try to estimate P, though, using only the people who came back to retest, assuming that we didn't have this information, with 3 different scenarios. One, where we had a high response rate. So this is where a large fraction of those 400 people came back to retest. And then in setting 2, we would have a moderate response rate. In setting 3, a low response rate. And we're going to look at how much bias we see in our estimate of the prevalence of high cholesterol. So go ahead and open up Stata and we'll get started. The data set we're going to use in this example is the Framingham non-response example data set, contained on the web page that you see. So now this is a data set that I made up. I randomly sampled 400 people from the Framingham population, and then we have whether or not that individual had high cholesterol, and then we have 3 different variables over here called high cholesterol A, high cholesterol B, and high cholesterol C. And those are the 3 different cholesterols under the different sampling scenarios we talked about, under the high response rate, moderate response rate, and low response rate. So what we're going to do is let's go ahead and estimate the prevalence of high cholesterol in the data set using the full sample of 400. We would just type proportion, high chol. If everyone would have returned, we would have gotten an estimate of high cholesterol that is 45.75%. So that's the estimated proportion among the 400 people who returned. We have 400 observations here. Now if I type codebook, high chol A, we actually have 306 out of 400 observations missing for high chol A. So I mix that up. High chol A is actually the high missingness scenario. In scenario B, we have 200 missing observations. And in scenario C, we have 81 missing observations. And remember, missingness, we expect it to be correlated with high cholesterol. Using the full sample, we saw an estimate of 45.75%. Now let's use sample C. That's the low missingness sample. So using sample C, we get a little bit lower of an estimate. We see that our estimate of high cholesterol is now 42.6. Now let's try B. So now we are only using 200 people to make inference about P, and we see that we have an even lower estimate of the proportion at 37.5%. And last, in scenario A, where we only use 94 observations, so this would be hypothetically only 94 people returned to retest their cholesterol, we get a very low estimate of 30.8%. Now, know what would happen if I would have tried to calculate the prevalence of high cholesterol all at the same time, including all these measures of cholesterol in the same time. You look down here and you see that you get weird results. You see that everyone has the exact same estimate of high cholesterol, and we're only using 58 observations. So this is one of those things with missing data in Stata. If I try to run the proportion command on a bunch of variables at the same time, it's doing a complete case analysis. It's only including the cases for which high call C, high call B, and high call A, for which all of those have no missing data. So that's why you're only using 58 observations here, and you get this ridiculously low measure of the prevalence of cholesterol. So always think about what your software does with missing data. So recall that in the full sample, we had an estimate of 45.8%. In the low missingness sample, we had an estimate of 42.6%. In the moderate missingness example, we had an estimate of 37.5%. And in the high missingness setting, we had an estimate of 30.8%. So we can really see illustrated very clearly here that when you have a response, when the probability of someone responding is correlated with the outcome of interest, so the probability of revisiting is correlated with whether or not this individual has high cholesterol, you're going to see bias increase with the amount of missingness in the sample. So you need to be very aware of that when you're conducting a survey and think about how to deal with non-response, which is a very difficult question. And it's also, unfortunately, beyond the scope of this class. But we can think a little bit about what we've done this week with survey weighting to see if we can uncover an unbiased estimate of high cholesterol from each one of these samples. So if we think about it, in the Framingham cohort, we have all this baseline data for all participants. So even if an individual doesn't come back to get their blood retested, we know all of these baseline factors about that individual. Therefore, using those baseline factors, we can use those to estimate the probability that an individual returns to have his or her cholesterol tested again. Now, if we knew the exact probability that an individual returned, we could obtain an unbiased estimate of high cholesterol prevalence at baseline. Essentially, this is just survey weighting. If we had a random sample, but people didn't show up, if we defined our survey weights as 1 over the probability that an individual showed up as a function of their baseline covariates, let's say we just knew this somehow, this is essentially just a survey weight. And so if we just weight our data by this weight, we can recover an unbiased estimate of the prevalence of high cholesterol in our sample. So because I'm sort of the oracle here who knows exactly the probabilities that these individuals would revisit, I've given them to you in the data set. We have PA, so this is the probability an individual would revisit under scenario A. PB is under scenario B, that's the moderate missingness scenario. PA is the high missingness scenario. And then we have PC, the probability of revisiting under the low missingness. So now think about this. If we're weighting individuals by 1 over the probability that they return, the people who are less likely to return are going to get larger survey weights, and they're going to represent more people in our data. So these people who are less likely to return get more weight. So they're representing the people with high cholesterol or with a higher chance of having high cholesterol who just didn't show up. And that's really the basic idea of survey sampling, is that you want to make sure your sample is representative of the population. So in our analysis, we saw that in this really high missingness scenario, we underestimate high cholesterol prevalence because people with high cholesterol are less likely to show up. By using this weighting scheme, we're going to put more weight on the people who do show up, but we didn't expect them to show up, they're going to get more weight, and therefore we should be able to recover an unbiased estimate. So let's try it out. So first we need to generate our survey weights. We're going to type generate WA, our weight for scenario A, is equal to 1 divided by the probability that an individual shows up under scenario A. We see that there were 2 missing values generated when we do this, so we're actually going to drop those 2 values from analysis. So now we're only making inference using 398 people. Do the same thing for scenarios B and C. So once we've generated these weights, let's run the proportion command again. You could either survey set your data as we learned how to do previously, or you could just say proportion, high cholesterol A, and then in the brackets type in your probability weights. P weight equals WA. And you could do the same thing for scenarios B and C, and for the total population of 400. So let's look at what happens when we weight. So for the full sample of 400, we got an estimate of 45.7. For the low missingness scenario, we get an estimate of 45.3. Moderate missingness scenario, 45.1. High missingness scenario with only 92 observations, we get an estimate of 45.57, which is really, really close to the estimate we get if we would have had all 400 individuals available in our sample. So this is neat, right? As long as you define your weights correctly, you can recover an unbiased estimate of the prevalence of high cholesterol in your sample. We've essentially taken a very non-random sample A with a lot of missingness and a lot of informative missingness, and by defining weights correctly, we've made our sample essentially look like a simple random sample, like we have here in the sample of 400. So this is the whole idea of survey weighting, is to weight your sample such that it's representative of the entire population. Now, many methods have been developed to address survey non-response, such as multiple imputation or weighting for non-response, but as I said before, this is a very complex issue. It's beyond the scope of this course, unfortunately, but I recommend that you take some time to read about it if you're going to be conducting a survey yourself. Every method for handling non-response has limitations. Therefore, maximizing the response rate is always a great policy.